Hello, it's time for another math video. Yay! Today's video is about comparing decimals. We're going to look at which one is bigger, which one is smaller. But since we are doing both positive and negative, sometimes bigger is less and smaller is greater. Remember the difference between bigger, smaller, less, and greater. Okay, let's start. Okay, first, here are the comparison symbols. Don't mess them up. The first one is greater than. That one is greater than. This one is less than. This one is equal to. Whatever way you want to remember it, that's the right way to remember it. Is less than turns into an L for less than. Put an is in front of it and you've got it. Whatever it is you need to do to remember, remember it. Okay. First, we have to talk about decimal place value. Here's a decimal point. If I have 7.13, the 3 is in the hundredths place, the 1 is in the tenths place, and the 7 is in the ones place. If we had 671 and 342 thousandths, then the 2 would be in the thousands place, the 4 in the hundredths place, the 3 in the tenths place, the 1 is in the ones place, the 7 is in the tens place, and the 6 is in the hundredths place. I have this weird idea, and absolutely no one in the world agrees with me. I just think it would be much better if the decimal point, instead of being between the ones and the tens place, would be underneath the ones place. Then it would be symmetrical. 10 would go with tenths, hundredths with hundredths, but I am not the king of the world. No one agrees with me, so that's not the way things are. This is the way things are. Hundreds, tens, ones, decimal point, tenths, hundredths, thousandths. Okay, so those are the decimal place values. But what does that mean? Well, here are what I call 10 by 10 grids. Every grid here is 10 this way and 10 this way. And 10 times 10 is 100. So these are 10 by 10 grids. If I wanted to do a number like 0.2, that would be 2 tenths. So I would shade in 2 of these lines because there are 10 of them all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tenths is 1 whole. So that's 2 tenths. If I wanted to do 0.4, that would be 4 tenths. 1, 2, 3, 4 tenths. That would be 4 tenths. But what are the little ones for? Well, as I said, there are 100 little teeny tiny squares in this. So each of them is 1/100th. So if we had 0.02, that would be 2 of these little tiny pieces. 1, 2. That would be 2 hundredths because it's 2 out of 100 little teeny tiny squares. So what does that mean? Well, what it means is if I wanted to graph in 0.37, I would shade in 3 tenths. So 3, 2, 3 tenths, and 7 hundredths. 3 tenths and 7 hundredths. And so you might say to me, well, what would this one be? Well, how about 0.5? Well, which one do you think is bigger? Is 37 hundredths bigger or 5 bigger? I have had students tell me that 0.37 is bigger because 37 is certainly more than 5. But let's see if that's true. If it's 5, that 5 is in the tenths place. So I'm going to shade in 5 tenths. 1, 2, 3, 4, 5. Well, which one has more shaded in? 5 tenths does, because this only has 3 tenths and a little piece of the 4th tenth. This one has 5 tenths. It has 3 tenths, another whole tenth, and another whole tenth. So what matters is the first digit that you see. The 0 and the 0 are tied. The 3 and the 5 is next, and the 5 wins, and we can ignore the 7 because it's just too small. So let's take another extreme example. In this case, I'm going to put 0.09. Now 9 is certainly more than 7, and 9 is more than nothing, so this of course must be bigger. But let's see what that would be. 0.09. Well, that's 9 in the hundredths place. So I would only shade in 1, 2, 3, 4, 5, 6, 7, 8, 9 in the hundredths place. That is less than 1/10. So that would not work at all. Now you might also say to me, Mr. Zengerle, what about the thousandths place? How would that work? Well, I'll try it. Let's try 0.273. Okay. Well, how many tenths are there? There are 2 tenths. So I'll shade in 1/10 and 2 tenths. Okay. Now, how many hundredths are there? There are 7 hundredths. So I'll go 1, 2, 3, 4, 5, 6, 7 hundredths. Now, how many thousandths are there? Well, there are 3 thousandths. So that means that I have to draw 10 little bitty lines here. Actually, 9 lines to make 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I shade in how many of them? 3 of them. So 1, 2, 3. Look how tiny that is. That's barely anything. It is so small that we don't care about it. But what if I change this number over here and I make it 5? I'm going to change this one completely. I'll erase it. And I'm going to make it 0.274. Well, I'm still going to do 2 tenths. I'm still going to do 7 hundredths. And then I still have to carve in and make 4. I make 10 of them. Really teeny tiny. 5, 6, 7, 8, 9. And then I need to shade in only how many? 4 of them. 1, 2, 3, 4. Okay, let's compare these two. 0, 0 tied with 0. 2 tied with 2. 7 tied with 7. 4 is bigger than 3. So just do that. Look at each digit one at a time. Look at ones with ones, tenths with tenths, hundredths with hundredths, thousands with thousands, until you find a difference. As soon as you find a difference, stop looking. All right, here is a number line. It goes up to +2 and down to -2, and in between there are 10 tenths. So I can graph on this number line. Let's write down the number let's say 1.4. Let's find where that would be. Well, let's focus in. This is positive, so I'm going to focus in. I'll start here at 0. I'll go up to 1, and then I need 0.4 more. So that would be 1, 2, 3, 4. And by the way, points go right on the lines. I've had teachers, some old teachers sometimes put their points next to the line. Points go on the lines. So we'll erase the ones we don't need. That's where 1.4 is. Let's try another number, 0.8. So I'll go in here, I'll graph 0, it's less than 1, so 0.8 should be 2 short of 1, that should be 0.8. So let's compare them. Which one is on top? 1.4 is, so 1.4 is greater than 0.8. If we look at the digits, we'll look at the ones place. 1 is bigger than 0, and I can ignore the rest. All right, let's look at the bottom part here. Let's change it, and now I'm going to change it to negative 1.4 and negative 0.8. Okay, let's graph that. First of all, it's negative, so I have to go down. Here is 0, here's negative 1, and negative 1.4 will be right there. That's negative 1.4. Then negative 0.8. Well, it's between 0 and negative 1. 1, 2, 3, 4, 5, 6, 7, 8. Oops, forgot to change. Negative 0.8. Which one is higher? Negative 0.8 is higher. So now, negative 1.4 is less than negative 0.8. And that makes perfect sense because, as you know, the bigger the number is in the negatives, the lower down it is. More negative is less than. Less negative is greater than. And of course, 0.8 positive is greater than negative 1.4 negative because all positives are greater than all negatives. Okay? So let's move on. Next thing. Let's look at these and let's compare them. All right? First, these are positive. So the bigger one will be bigger, will be greater. So 3 is tied with 3. 8 is less than 9. So this is less than. Let's try the next one. This has nothing in the tens place. This has 4. So 45.1 is much bigger than 7.4083. However, 7.4083 is positive and negative 45.1 is negative, and all negatives are greater than all positives are greater than all negatives. Let's look at this. These are both negative, so now we want the less negative one will be greater. The less negative one will be greater. Negative, negative, 7 is 7, 2 is 2, 8 is 8, 8 is 9. 9 is more negative than 8. 9 is more negative than 8 in the hundredths place. The fact that there's a 7 there and a 4 there, ignore it. It's too small. Imagine it's these grids. It would be these little tiny things. They don't make any difference. They're much too tiny. So this one is more negative, so therefore it is less. This is greater than because this is less negative than that. So on the number line, it would be like this one is greater than this one because it is less negative. All right, D. These are both positive. This is 325 and 1/10. This is 700. Isn't 700 more than 300? I mean, the next number up would be 400, and 400 certainly less than 700, so this is less than. All right, that's how you compare these numbers. Do your best. Bye.